2, a stone is thrown vertically upward and it returns to the thrower 3.2 seconds later. What is the stone's maximum height? So this is where we toss it up and it comes back down. So I'm going to draw a little diagram because that kind of helps to visualize, well, what's really going on here. So I'm starting, I toss it up, it goes to a maximum height and then falls back down. So right here, this is max height. At maximum height, I know my v is equal to 0 meters per second. I assume that it's going to free fall back down. So since I'm tossing something up and it's coming back down, I'm going to label my acceleration as negative because I have kind of two, because things are going up and down. Okay? So A is equal to negative 9.81 meters per second squared. T we're told that the all total time is 3.2 seconds. But remember, we're trying to find our maximum height. So this time that we were given is from when I threw it to when it falls to the ground. So we need to do something with our time to figure out what's the time right here. So an assumption we can make is our max height occurs at half time. Okay, so you go t divided by 2 here for this spot. So this is very important assumption that we need to make sure that you've written down and that you know. So since we're looking at our max height at this spot, I'm going to divide my t into 2. So the time I need to use is 1.6 seconds. I'm only looking from here to here. So in reference to this question, the way that what I'm looking at, this is VI and this is VF. I know at VF it's equal to 0.0 meters per second. And I'm trying to find my D. What is this maximum height, okay? What is that D? That's what I'm trying to find. Now we can look and see, is there a formula that has all of these variables in it that I can use?
Why wouldn't you put your VI in it?
Pardon me?
Why wouldn't you put VI in it?
Because I don't know my VI. I don't know the speed that it was thrown. Yeah. I can't assume that it's 0 because it's when it's thrown, and I wasn't told that information. Good question. So your formula you need is D is equal to VF T minus half AT squared. Since I know my VF is 0, I can cross this part of my formula out because whatever I multiply by 0 is going to be 0. So now I have D is equal to negative half AT squared. Make sure that you don't just let that negative disappear into space, okay? It's super important. So even though I took this out of the equation, right here is still a negative. Now I can plug it in. So D is equal to negative half, times by negative 9.81 meters per second squared, times by 1.6 seconds, and that number is squared. Okay, remember, you have to square the t. So you got to be really careful about your writing because even though your units for acceleration is meters per second squared, you don't square this number that you need So just make sure that you're writing out your work and that you're being clear with your units. Yep.
Why is the 9.8
Because in this question, I'm throwing things up and down, so I need to look at my acceleration as being negative. Because it's, when our question is that like an object is being tossed up first and then back down, your A needs to be negative. Because it's like if you toss something up, the acceleration is acting against that. Good question. Okay, so your answer should be 12.5568 meters. So to sig digs, that's 12.6 meters. Again, this is not displacement. We're not asked to give a direction because we were just asked to find the height of something. Okay, and that's in reference to the ground up. So no, because this negative multiplied by a negative will give you a positive. Yeah. So 2B, so this is in reference to the first question, but now it's asking us, or the second question, sorry, it's asking us what is the velocity of the stone when it is released by the thrower. So that was what, Dylan, you were asking, well, what's initial velocity? So this is what that question is asking us. So I'm just going to make a note to myself, velocity. This is a vector, so my answer needs to include a direction. What direction will it probably be? It's going to be up. Yeah, so I know my direction is up. So there's actually two methods to go about doing this question, so I'll show you each one. So method number 1. So I'm thinking about throwing the ball up. So this is VI and this is VF at max height. I know my VF is 0, and this occurs at t divided by 2. VI is what I'm looking to find. What is my velocity as it's being released? I know that my VF is equal to 0. I know that my time is 1.6 seconds here. I should just clarify, t half is equal to 1.6 seconds. And since I'm throwing it up, I refer to the acceleration as negative, so 9.81 meters per second squared. So what formula involves A, T, VI, and VF? For this purposes, this is T for our question. So remember there's that formula, pardon? Yeah, A equals delta V over delta T. Because we know that delta V really means VF minus VI. I can cross off my VF because that's 0. So I'm going to simplify this and say A is equal to negative VI over T. I'm trying to find VI. So right now VI is divided by T, so I multiply by T, multiply by T. So I get A times T is equal to negative VI. I want to, you can keep the negative there or we can put it on the other side. I prefer to put it on the other side, so you can just transfer it over. Either way is fine. Okay, so now we plug it in. So the negative of negative 9.81 meters per second squared multiplied by 1.60 seconds is equal to VI. So 15.696 meters per second is equal to VI. Again, I'm going to put this into sig digs, 15.7 meters per second. And I know since this is a vector, as we already discussed, I'm going to label it as up. Everybody good? Okay, you want to see the other way? I know you do. It's very exciting. Okay, method number 2. So if you ran out of room, you could take another piece of paper or whatever. Okay, so method 2, it's just a different way of looking at. What?
Just show if you have any.
Yeah. If I can find it. Okay, so method 2, we just think about it a little bit differently. We decide that something else is going to be VF. So I know that I toss it up and it comes back down. Now I'm going to say that this is VI, same spot, but where it ends is VF. So I'm going to say, I'm going to make the assumption that where VI is equal to negative VF. So I'm still trying to find VI is equal to question mark. I make the assumption that VF is equal to negative VI. I know that my A is equal to negative 9.81 meters per second squared. And my T, because I'm looking at the whole time from start to finish, so I say that T is 3.20 seconds. So I still use the same formula, VF minus VI divided by T. But I'm going to substitute what I know VF is equal to. So I say that A is equal to negative VI minus VI. Okay, this came from this. So I said that VF is equivalent to negative VI. So I put that in for where I had VF. And then I still say minus VI. All divided by still by time. So A, really, if we are to summarize this, would be equal to negative 2 VI divided by T. Since I'm solving for VI, I go A times T divided by negative 2 is equal to VI. So I go negative 9.81 meters per second squared times by my T, which is 3.20 seconds, all divided by negative 2. It's going to be the same thing. Put it in your calculator.
Well, it better be the same thing, it's just the same question.
Same thing.